This lesson is for the Unit 8.A.1 notes, but it starts off with the warm-up that I wanted to show the answer key for. This is also posted on the website. This video should be as well. But we're going to walk through a couple of the steps, but the additional practice, if you decide to do those, I'm not going to leave this up for too long, so you can always check the answer key that's posted if you decide to do those, plus the answers are labeled below. So for BC, to find segment BC, if you look and see how it corresponds to the 10 that was given for DG, you would have to use corresponding triangles to do this, though, because there's no theorem that lets you correspond those using some kind of shortcut. Like, it's not the three parallel lines proportionality theorem or the triangle proportionality theorem. None of that will work. Instead, if you know that GD is 10, you can look at the triangle that corresponds with GD and the side that corresponds that you want to use, which would be like the 15. Then, if you're going to find this BC that we're looking for, which I already found, but if I was looking for that, I would use this entire side here, which came out to 20. So that was my proportion I used. Yours could look a little different depending on which sides you wanted to put against what. So I did BC over 10, which meant I needed to do 20 over 15. And then just cross multiply and solve. And you want to leave exact answers, so don't write it as a decimal. If you did divide 15 from 200 divided by 15 on the calculator, it gives you 13.3 as a repeating decimal, so you should write that as 1/3, 13 and 1/3, or write it as an improper fraction if you'd rather do that. So then to find the next one, AG, the easiest way to do this, and I was trying to do a proportion at first, the quickest and easiest is that because this is a right triangle, why not use Pythagorean Theorem? Because that's exactly where we're headed today. And we know what Pythagorean Theorem is because we did that kind of earlier in the first unit. So we can just do a squared plus b squared equals c squared. That's what my work shows. And then you want to write your answers exact again, so we left it in simplified radical form. So you should get 5√13. Okay, so check over those. And then the last two, though, to find GC, you had to use another proportion, which the easiest one was the three parallel lines proportionality theorem, or you could look at it in terms of the triangle proportionality theorem, actually, because you kind of treat it as two triangles instead of these extra, kind of ignore FE entirely. And since this is right angles with straight lines, we know that these would have to be parallel. So that's why we're able to use the triangle proportionality theorem. And so here's my proportion using the answer I got from AG. So this whole side corresponds to the 15. So 5√13 over 15, and then GC was what we were looking for, this little section, over the corresponding section 5. All right, so for those two, though, the last one, also you got to use the area formula for a trapezoid. It's all kind of review. This trapezoid stuff isn't going to come up too much in this unit, but this was just always good to practice some old skills that you should know. So we're going to move on, though, to the new part, which is 8.A.1, dealing with Pythagorean Theorem and its converse. So we're going to just do a quick recap. All this should look familiar because you've seen it before. So let's start off with, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So really just saying c squared is the square of the hypotenuse equal to the sum a squared plus b squared of the squares of the legs. And then the converse would basically tell you it's going to go the other way around, where if the square of the length of the longest side, which again is referring to the hypotenuse, is equal to the sum of the squares of the other two sides, which are then the legs, then the triangle is a right triangle. If you're, again, using a squared plus b squared equals c squared, and that does hold true, then the triangle, in this case ABC, is a right triangle. All right, so let's go on to try out some examples. Now, everything you've seen before today, like in Unit 1 when we've done Pythagorean Theorem, a lot of it's going to look similar today. We're just going to do it in context now. Lots and lots in context for this unit. So let's start with the first example. It says here, Carrie made a ramp for her dog to get into her truck. The ramp is 6 feet long and the bed of her truck is 3 feet above the ground. So the hardest part of these is drawing a correct diagram that goes with the proper measurements. and then to find the final answer using Pythagorean theorem for this first day today. It says to the nearest hundredths, approximately how far from the back of the truck does the ramp touch the ground? So let's do a little sketch. So for the sketch, we're gonna trying to like visualize. You know, you have a ramp. That's like the part that's like the sloped part, like the hypotenuse. You can kind of imagine the ramp itself is 6 feet long, and it's hitting the bed of this truck. So right here, this is going to be where the truck starts, and the truck itself is 3 feet above the ground. So this would be 3 feet. The ground is right at the bottom here. It's going to form a 90-degree angle with the truck kind of hitting the ground here with the ground is 90 degrees. And those are the two measurements we have so far, but the question's asking how far, so this is where the ramp touches the ground, right? So this is the ramp. This is the bed of the truck. So this is the height. Kind of imagine like a whole truck here. I'm not going to draw it all out, but you can imagine the whole truck with the wheels and all of that on the ground. And then you are trying to figure out how far to the back of the truck does this ramp end touch the ground. So this is x that we're looking for. So we would use Pythagorean theorem here. You know the hypotenuse in this case, so it's 6 squared equals 3 squared plus x squared. You don't have to show every little step on these examples. If you want to, you can, but I'm just going to go ahead and do 36 minus the 9 that you would get here, and this comes out to 27. When we write our final answer, make sure you read whatever it says. In this case, it wanted us to round to the nearest hundredths. If it did say to write in simplified radical form or write an exact answer, that would be 3 root 3, because the perfect square sitting inside 27 is 9, but in this case we want to round. So this comes out to approximately 5.2, and the units are feet. So we found out how far away the bed of the truck is from when the ramp hits the ground. Okay, let's try another one. Seth is trying to make a small rectangular table. He's trying to make a small rectangular table for his workroom. The sides of the table are 36 inches and 18 inches. And if the diagonal of the table measures 43 inches, is the table a square? So basically saying in order for it to be a square, it would need to have right angles. So we are checking for that because if you think of a rectangle, we know if it's a small rectangular table, it's got to have 4 right angles. But let's look at the measurements here. Sides of the table are 36 by 18. So imagine 36 and 18. And then if I want to, it says the diagonal of the table. So here's my diagonal. That's measuring 43 inches. Now I have to check, is there going to be a right angle here? When I draw this out, all of the right angles could be drawn out here to check to see if this will be a right triangle or not. Right? So I can label it anywhere here. They're all 18 by 36. But I have my right triangle to look for, is 18 squared plus 36 squared equal, I'll put a little question mark on top of the equals, equal to 43 squared. And so you've got to use a calculator here. 43 squared comes out to 1,849, but these two added together, it's 1,620. So clearly not the same. So no, the table would not have right angles. So what we just did with each of these examples is we did one where we applied the Pythagorean theorem. Now you might say, well, didn't we apply it on both? Well, technically you use the converse of the Pythagorean theorem. So it does say for questions 1 and 2, which problem did we use the Pythagorean theorem and which one was it the converse? So we use Pythagorean theorem on number 1. So just the actual theorem on number 1, where we had to just find the missing length, right? But for the converse, so we'll just say missing length. But anytime you're asked to show if something is a right triangle, which is what we were trying to show here in order to have a rectangle, we would have for the converse. So it says converse of Pythagorean theorem would be number 2. And the main idea for that one was that we were trying to see if it's a right triangle. So anytime you're trying to figure out right triangle or right angles, that's kind of the idea when you would use the converse. Okay, so let's try a few more examples here. A newly planted tree needs to be staked with 3 wires. Each wire is attached to the trunk 3 feet above the ground, and then anchored to the ground 4 feet from the base of the tree. This is a lot of stuff we're going to have to draw out. And then let's say we need the wire for 6 trees. Okay, so we're going to do the work for 6 trees. Draw yourself a sketch. Here is my tree. Nothing fancy here. But if I have my tree, and the bottom of the tree obviously would be the ground, it's saying here that when you plant the tree, it has to be staked with 3 wires. So 3 is an important word there, but let's work with each wire for right now, because I'm not going to draw all 3 because that would be tough to kind of draw out here. You can kind of imagine it, but I'm only going to draw one of them. So when I stake, let's do one of the wire, because it says it's attached to the trunk 3 feet above the ground. So imagine here, there's the ground, 3 feet high. That's where this wire will come from the tree, probably from the trunk actually, and I'm drawing it from higher, but it should technically come from the trunk itself, from 3 feet. And then let's see what else we have here. It says, then anchored to the ground 4 feet from the base of the tree. So this has to be 4, because this is the base of the tree, and this is where you anchor it to the ground. So this is a wire. That's one of the 3 wires that you're putting on this tree. There's another one this way, probably either forward or backwards. We can't really see all of them, or how you would draw it. So the measurements are, again, 3 and a 4. There's a right angle here. And we're trying to figure out how much wire would be needed for this one wire. But remember, it's times 3 because we have 3 of them. So you can write down a couple of important things here. Each wire is, let's figure out what we're going to find here for the actual Pythagorean theorem. We're going to say how long each wire will be. And then from there, we're going to multiply, because you'll know how much each tree will need. Each tree, remember, has 3 wires. So this would be times 3. Whatever answer I get from above, we'll have to multiply times 3. And so each tree will need whatever amount of wire. And then finally, there are 6 trees. So you would multiply that answer by 6. Okay, so let's walk through this. First of all, there's something called a Pythagorean triple, which we're going to actually see on the next page down here in just a couple of minutes. These are common Pythagorean, what always will hold true for Pythagorean theorem. One of them is 3, 4, 5. So when I see 3 and 4 for a leg, I would be able to memorize this, but it's always going to be 5 for the hypotenuse then. So this would be 5 feet. Now, if you're not sure of this, I'll put in parentheses Pythagorean triple. That's the quick way that I would do it, because I would identify it, but right now you haven't really gone through the examples yet. But it would be 3 squared plus 4 squared equals c squared, and then you could solve and see that it does come out to 5. Okay, but that's just for one wire. There were 3 wires in each tree, so 5 times 3 is 15 feet so far of how much I would need for each tree. And there are 6 trees, so I would multiply 6 times 15, so that the total amount of wire that I would need would be 90 feet. 15 times 6 is 90 feet of wire in total. Okay, so we had to definitely walk through that. That can happen at times with Pythagorean theorem, where obviously you can do the theorem, but then you have to do kind of some work after it. Here's another one where we may need to do some work to follow up, because we're trying to find the area of this isosceles triangle. We're going to say the base is 24 centimeters, and then the legs are 20. Let's draw a diagram. So here's an isosceles triangle, which means the legs are congruent. The legs themselves are 20 centimeters. And in order for me to do this, because I want to work with right triangles, I want to draw down this altitude, which is also a median, because this is the perpendicular bisector theorem that shows that if these are equidistant, then technically this segment I just drew is a perpendicular bisector. So the base, even though it's 24, each of these now are 12 and 12. So I need to find h, or my height, this altitude or this median or perpendicular bisector I've just drawn in using the measurements of this triangle. So if you need to kind of split the triangle up, you can. Where h is the height I'm looking for, 12 is this base at the bottom, 20 is the hypotenuse. Use Pythagorean theorem to first find the height. So here is 20 squared equals h squared plus 12 squared. I'm going to just go right to the answer here, which came out to 16, because once you subtract the 144 from 400, you do get the square root of 256, which is a perfect square. and then go to your area formula for a triangle. 1/2 base times height. The base is the entire base here, 24, and the height would be what we just found, 16. And use a calculator as needed. This is 192 square centimeters for the area. All right, let's try a few more. A 6-foot board rests under a doorknob, and the base of the board is 5 feet away from the bottom of the door. So we have a door here. Here's my door. Doorknob. And it says there's a board that's laying under the doorknob, and the base of the board is 5 feet from the bottom of the door. So let me draw it like here. Here's the actual board. That's like a little rectangular piece probably, and it would be something like this. The board itself, it says, is 6 feet long, and it's 5 feet away from the bottom of the door. So this is the bottom of the door, 5 feet away. We're trying to figure out how high is the ramp, or is the board sitting above the ground. So the height here. Okay, and so to do this, we have Pythagorean Theorem again. 5 squared plus x squared equals 6 squared. That would be 36 minus 25, which comes out to 11. And then when you square root it, you could just get the square root of 11, though they did say to round here. So we're going to round this to 3.3 feet, approximately. That's to the nearest tenths. All right, if any of these don't quite make too much sense here, we'll definitely go over them on Friday, so you can definitely bring your questions in as well. All right, here's a few more. Anna has let out 50 meters of kite string when she observes that her kite is directly above Emily. If Anna is 35 meters away from Emily, or from Emily, how high is the kite? So imagine a kite up in the air. Here's my kite, and obviously kite has some string to it. So here's my string that's hanging down. Anna is obviously, when she's flying this kite, let's say this is the string here. This is Anna, A for Anna. That is 50 meters. That's how far she is away from how much string she's holding. That's how much string that there is to the kite. And then she's saying when she observes that her kite is directly above Emily, so Emily has to be directly below here, straight line down. It's saying how high is that kite. So we're going to find out how high from Emily. The distance away from Anna and Emily when she does this is 35 meters. So again, definitely practice drawing these diagrams. If you want to even eventually grab a blank copy of this and see if you could draw your own diagrams before the next assessment, which is not for a few days, but you could definitely do that. So again, Pythagorean Theorem, 35 squared plus x squared equals 50 squared. And when you subtract 35 squared from 50 squared, you should get 1,275, and we square root it. And you get about 35.71 if you round this one. It can be written as a simplified radical as well, so it didn't specify here. I'll write both. 35.71 meters. If you were to round this to write it in simplified radical form, 25 is a perfect square sitting inside 1275. So this would be 5 root, and then 51 is what gets left over, meters. So again, both answers are there. Just depends on a quiz or a test how you need to leave that answer. All right, so we have a couple more examples on the next page, and then we summarize what that Pythagorean triple is, like I mentioned right here. But really the best way to get better with those triples is just to memorize them, which we'll see on the next page again. And we'll kind of see them throughout this unit, so anytime it comes up, I'll remind you that that's what it is, but it does help to just practice it on your own. All right, so a lifeguard in this example spots a drowning swimmer 40 feet from the beach. So if we identify where the lifeguard is, there's a lifeguard. The water is here. Obviously, lifeguard's not in the water. She has to run along the beach. This is where it's just sand. And then she has to go, because the swimmer is all the way down here that's drowning. So she has to run 90 feet along the beach first. Then she's this speed here is at 15 feet per second. That's the speed she's getting through. So we could technically find how much time. We'll do that in a minute. And then she jumps into the water, swims straight to the swimmer. Now we don't know this distance, which we need to find using Pythagorean Theorem. And then once we find that, we know the speed is, let's do 5 feet per second. If that's her speed, then we can figure out how long it takes her to get to the swimmer. But first of all, you're going to do Pythagorean Theorem, 30 squared plus 40 squared equals x squared. Now this one is another Pythagorean triple. Remember 3, 4, and 5? These can get multiplied by any number, so they all have zeros at the end of them. That's another common one to do. So x is 50 feet. That's the distance that she has to swim to get to the swimmer in the actual water, like the straight distance instead of going across and down like this. But now let's think about time. So in order to find time, this is like a little equation that can be used. Distance equals rate times time. Something you're going to definitely learn in physics and other classes eventually with science, but we do cover it a lot in math as well. So anytime I know a distance and I want to find a time, if I wanted to solve for t here, I could divide by r. So to find my time, how long it takes for each scenario when she's running versus when she's swimming, I'll have to take my distance and divide it by rate. So the rate for the running is 15 feet per second, and 90 feet is how far she needs to go. So 90 divided by 15 will give me how much she's running for, which comes out to 6 seconds. This is for when she's running. Do the same thing for when she's swimming, which is 50 feet over 5 is her speed, 5 feet per second. So that takes her 10 seconds to swim in the water. So this is the swimming part. We need to combine both those to see how long does it take in total for her to reach the swimmer for when she starts running to when she swims and meets the final goal, which is 16, right? All those added together, 16 seconds is how long it'll take to reach the swimmer. Okay, so a lot of these in context problems take it kind of one step further after you do the Pythagorean theorem. All right, and we just have 2 more examples here, and then we'll summarize the triples like I've kind of mentioned already. The next one, and we're going to do a lot of this coming up in the next few days, but each one will look kind of different. So for this first example, it says find the area of the regular polygon to the nearest hundredths. Don't round any of your calculations until your final answer. That's kind of tough to do. If you have a graphing calculator, it does make it a little bit easier, though you can do this all with the scientific calculator as well. I would not advise using your cell phone calculators just because it can get just confusing with like parentheses and things like that. All right, so starting with the measurements given, AK is 8 meters and NM is 9.4. Now, in order to find an area of a regular polygon, we're going to eventually get an actual formula or an equation to help you find it. For right now, if you look at the diagram, though, regular means all of these sides are the same. And all of the angles are the same as well. So if all of these angles would be the same, it's going to create isosceles triangles in here. So if I kind of imagine each of these legs in here for these triangles, they're all going to be the same as well. So what I can do is technically I could find one area of one triangle and multiply by 5 because there's 5 triangles in here. So this is a pentagon, but again, regular means all sides are congruent or equal. So regular, so all sides congruent. So they're all 9.4s all the way through. And here's how I can work with just one triangle. Okay, so I know 8 meters on either end. That means this is an isosceles triangle, 9.4 on the bottom here, but I'm going to draw in the straight altitude here to form a 90-degree angle. This, remember, is not just an altitude, it's another perpendicular bisector. It's going to bisect those segments. If we need that information, we'll use it, which we will, because we're going to work with, we need to find this height. If I'm looking for the height, because in order to find the area of a triangle, like we did on the front page, you need the area of, the base and the height. So when I cut this in half, the 9.4, it turns into 4.7 for each of those. So that's 4.7, this is 4.7. And I have h I'm looking for, the hypotenuse is 8. So use Pythagorean theorem to first find h. So it's h squared plus 4.7 squared equals 8 squared. And when I go to my calculator here, I want to do 8 squared minus 4.7 squared, and I get this answer, 41.91. But when you square root it, make sure you keep the entire answer. So square root of this. Now this answer here is a decimal that just kind of keeps going like this, all those numbers. So you want to write down, you can write down a couple of them, but please make sure on your calculator, try to use the answer button, and I'll show you where that is on a graphing calculator. If you don't have a graphing calculator, you can technically use it on scientific ones as well, but it's just better to not round early on because your answer will get affected. So if this is what I have so far for my h, I'm going to use that in my formula for area of a triangle. So area of triangle, any of these triangles here, would be 1/2. The base of the entire triangle is 9.4. The height, I just found this answer, so it'd be 6.473, and so, etc. I'm not going to write the whole thing, 4738, let's say, but it's better not to round it officially. Actually, just so you know, I'm not rounding it. I'm going to go ahead and write up until the 7-9, but on my calculator, I'm going to use the answer key button, so it uses the previous answer. So this will get me the area of the triangle, and then to get the total, I just have to multiply by 5, because there are 5 triangles. So let's see what we get for this guy first. 1/2, so 0.5 or 1/2 times 9.4, and then look how I get the answer button. I press second, and down at the bottom here, where the negative sign is, if you press that, it shows you the answer button. So that way you don't have to kind of recopy this previous answer, or you could type in square root of 41.91. That would also work because that would keep it an exact answer. And then you get this answer here, which again, you don't want to round here just yet. We'll go ahead and multiply that by 5 because there are 5 triangles. So just hit the times 5 button. Notice again, use the previous answer. And I can round only at the end now to the nearest hundredths. So my final total area is 152.13. And the units were meters, so it's meters squared. That is the final answer. But again, better not to round until the very end, because if you had rounded every step of the way, your final answer would not look like this. It would probably be a little bit off. All right, let's try one last example, and we will do more with this kind. There's going to be, again, another formula that we'll get officially for regular polygons, but until then, we can always try it out this way. So it says one leg of a right triangle is 2 more than twice the other leg, and the hypotenuse is 1 more than the longer leg. Find the perimeter of the triangle. Actually, you know what? I'll draw this one, but we're going to actually skip this question because there won't be something similar on the test, and I want to make sure you get some time to get through this video, and then also if you have questions to bring them tomorrow. So the main idea here is that's what you end up getting once you think about the options here, because if the leg of a right triangle is 2 more than twice, you want to do 2x plus 2 more, and the hypotenuse is 1 more than that longer leg, so it's just plus 3. So that's how you get those, and then in order to find the perimeter, you would do Pythagorean Theorem with these expressions, which I don't believe is on the homework or on future quiz or tests. If it does come up, we'll go over this one eventually. I want to just get to the last step here, which is, it says a Pythagorean triple. So Pythagorean triple, oops, T-R-I-P-L-E, that's not theorem. Pythagorean triple is a set of 3 positive integers, a, b, and c, that would satisfy this equation. And so these ones are the common ones that you should just memorize, because anytime you see 2 out of the 3 numbers, you can just automatically know the third one. Rather than having to do Pythagorean theorem to get it, this would be the quickest way. It also works for, so here are like the multiples of them. So if you notice from the first column or row to the next, they multiplied everything by 2. So this would be 24 because 12 times 2. The next one multiplied, this would be 16, 30, and then 34. The last one, 14, 48, and 50. So you don't have to memorize everything in the second row. Just the bolded ones are these first 4 that you should memorize, because then you can use it for any multiple. So they multiply by 2 here, and then this just shows you can multiply by any number, like we did 10 above here when we got the 30 and the 40, and then that was 50. All right, so it just says at the bottom, note the most common Pythagorean triples are in bold. The other triples are a result of multiplying each integer by in a bold-faced triple by the same factor. All right, and then this is where we stop. I know these are a little bit long, so if you don't get through them all, we will go over it on Friday.